What is actually noise? Noise is a thermal agitation that the atom in an electrical component will gain energy and move random in fashion. They will collide with each other which results in release of heat energy. This heat so produces corresponds to thermal noise. A thermal noise power can be calculated with the formula KTB, where K is the Boltzmann's constant, T is the temperature, and B is the bandwidth. You can see in the diagram that its power spectral density is spread across the whole spectrum. The stochastic property of white noise, we can term it as the white noise is analogous to white light, which contains all visible light frequencies. A white noise generally have a zero mean. It is unpredictable as the noise samples at different instants of time are uncorrelated. Assuming zero mean, we say that noise has an infinite variance. To calculate the autocorrelation and power spectral density of bandpass noise, let's take this example and make the noise bandpass from -b to +b, that is a bandwidth of 2b with a magnitude n/2. With the formula that I have shown you earlier, we can calculate its autocorrelation function and the power spectral density, which is equals to NV. Again, it is a rectangle, a square, or rectangular signal. And on autocorrelation, that is on Fourier transform of that signal, we'll get a sinc function. Okay, this is the mathematical formula to calculate Fourier transform of a rectangular pulse, which will give you a sinc function. The noise channel capacity. We have often assumed that as the noise increases, the channel noise also increases. But this is not the scenario. We can see that for AWGN channel, that is additive wide Gaussian noise channel, as bandwidth tends to infinity. However, the channel doesn't tend to infinity, whereas it reaches a finite value. C equals to B into log 2 1 plus S by N naught B. That is the mathematical formula to calculate the channel noise, which gives me a finite value for an infinite channel noise.